I hope I'm audible now. So this is anonymous function means a function without a name. We're going to discuss the topic called anonymous function. Anonymous function means a function without a name. We can call them as closure as well. Some programming languages are specifically they call them as closure. Go generally you can use any name, either closure or anonymous function. Some programming language they say that there is little difference between anonymous function and closure, but Go, Rust and all you can use any name, either closure or anonymous function. Basically closure has got the scope of the variables, global variables. Anonymous functions also has got the scope of their global variables. Anonymous functions are very flexible in nature. It's pretty easy to use function. Only once you are going to call the function, anonymous function is a straight away approach. Fewer times you are going to use the function, you can even store it inside a variable. I will show it later and all. Let's see how to create an anonymous function and then discuss on the while creating. Function is the keyword. Input arguments here you're gonna pass the return arguments, the body of the function, and then the executor. This is the syntax. So this is the function. You don't give any name. So func is the keyword, you know that. And then the input arguments here you're gonna give. The return types you give. This is the body of the function. And this is the executor. This is the key area. The executor is really key area. Fine. Let's say I want to create a anonymous function just to execute. So print line hello world is the anonymous function. So it gets executed. The reason it gets executed is because of this. If this is not there, it could not be executed. I'll tell you. So this gets executed because of the executor. Let's say function AB integer. Integer is the return type. Return A plus B. Here you have to pass the arguments because this is the executor. This is also an anonymous function that has got input arguments, return type, return value, and also we are passing that values. So this should require a value because it's gonna give you the some add of A and B. You can print the value C. Right. The third anonymous function, if you see func A comma B integer return A minus B, I got to give it as F1. What is F1? F1 is not going to give you A minus B. F1 is a function. So a function can be stored inside a variable. Why it's a function? F1 is a function because there is no executor. It is a function. F1 is what? F1 is a function. You see that where F1. So technically you can create a variable like a function. So you can take it and F1 execute F1. Maybe 10 comma 20 equal to C2. You can execute the function. You need to find out the difference between this and this. So there is an executor. This is called the executor. So it gets executed and you get the value. But here there is no executor. Then you have to store the function. If without executor, actually you cannot create a function. Either there should be an executor or the function has to be copied to a variable. F1 is what? Actually, F1 is a function. Function can be a variable. That is how actually functional programming can be done using Go language, because a function can be a variable. In Go, a function can be a variable. How can a function be a variable? Like this, a function can be a variable. So what happened? Technically, I can create a function which contains integer, and then integer. I can directly assign a variable. If f2 is a function, if f2 is a function, what can I assign to f2? If f2 is an integer, I can assign integer value. If f2 is a slice, you can assign a slice. Similarly, if it is an array pointer, you have to give the address. So if f2 is a function, you have to give the function. Function could be anonymous function or a normal function with the same signature. Let's say I create a normal function, multiply a comma b, return a into b. I can give it as multiply, and then I can call f2. So what does it mean? A function can be a variable. You can assign a value to the function. What is the value to the function? If a function is a variable, what is the value? The value is a function. What you can do with the value, you can execute it as a function. So this is not an anonymous function, it's a normal function. Still you can assign this particular function to a variable, and then you can get a value. Okay, this is what actually the simple thing. Let's go to another example. Let me run this. Okay, everything got executed. So once again, just explaining, anonymous function means a function without name generally, but a function can also be assigned to a variable. You can either execute or you can store the function inside a variable. Okay, if you execute directly, you pass arguments with the function. You're gonna store it in a variable, then you have to store it within the variable and then execute that particular variable. So normal functions can be created as variable. This is very important thing. Function can be created as a variable. You can call them through variables. This multiply is a normal function. It's not an anonymous function, yet it can be assigned to a variable, and then this can be executed. This is what we have seen over here. Okay. Okay, let me go to the next example. Let me create a function called calculate, and then I have two variables, maybe a comma b, integer. But what this calculate has to do, it has to return. But what this calculate has to do, whether it has to perform addition, subtraction, multiplication, or whatever it is decided on a function that you pass over here. That means function of integer, and it got to return an integer. So return function of a comma b. This is what you do. You see this. So function is what here? Fn. F1 is a variable. What variable Fn is? Fn is a function variable, like a and b. Actually, technically, from the Go perspective, there is no difference between A, B, and then even the function. There is no difference at all. According to Go, A, P, and then F and three of them are same. But A and B we pass values, F1 we pass function. That's the only thing. So function, we are taking the function. We are not executing over here. You know that this is just a function. We pass the function. That means here the third parameter we have to pass a function. You pass the function, you access the value of A and B and execute it. This is what actually in some programming languages, especially this is called it as a closure. F1 has got the access to its global variable. What are the global variables of F1? You can think it of A and B are the global variables of function. Let's do this. Let me go to the result R1 equal to calculate of 10 comma 20 comma. The third one is called function. So you have to create a function return okay I1 plus I2. So what happened? So here you pass a function. What is the function I1 and I2? What I1 and I2 you are doing? I am returning I1 plus I2. So 10 and 20. So it goes here. F1. The F1 comes here. A plus B. These 10 and 20 are substituted over here and then return. Why? This has to return for this and then this has to return for this. So ultimately R1 you would get the R1. Fine. So you can go and then execute it. You get the function. Now what I do is I create a function called F1 like earlier, function of A comma B, return number, return A minus B. So F1 is a variable of type function. So this F1 is a variable. You can use it in wherever you can execute it, or you can use it wherever you would like to use it as a function. Then calculate of 10 comma 20 comma F1. You see the difference? So here I directly pass the function and execute it. Here I just pass the function. I create a function as a separate variable and executed it. Here I executed it, and then the third one, like the multiply we have done, multiply of A comma B, integer of return A into B. So multiply is a concrete function. It's not an anonymous function or it's not a closure or anything. It's a normal function. So I can see R3 equal to calculate of 10 comma 20 comma multiply. You see that this also can be passed as a variable because it's for satisfying the signature. Signature does not mean the name of the function, but the signature of the function. What input parameters are and what output return type is. Multiply of A and B is called R3. The fourth one, I create a type called function, which is of function of integer comma integer, which got to return integer. Technically you can create a type which is of type function as well. It's not, type is not only the structures, type is not only the interface and all, even the normal type on top of existing type. You can create even a function as the type. That is the most flexible. Because of this, actually Go can be used as a functional programming as well, even though complete functional programming constructs are different. Too much of they talk about the immutability of the variables, and then functions are the first class citizens. Functions are the objects, etc. But you can do kind of a functional programming with Go because of all these constructs, because of the Go's flexibility thing. When fn is a type, what you can do is you have to create a variable where f2 is of type fn, where f2 is of type f1. So what is f2 is created anywhere? Okay, f2 is of type f1 because f1 is a type. For a type, you always create a variable. I create a type called function. Here I create a type called function. You see that type called function. And then this function, I can create a variable of type function. Sorry. Whenever you create a type, you can create a variable. What does this variable contain? This variable contains a can contain a function I1 divided by I2 return. So what is function here? Function is a variable of type fn. What is type? Type is fn. In fact, actually you can create another methods to fn as well because it's a type. Any type you can add methods. So fn is what? Let me put it as fn1. What is fn1? fn1 is a variable of type fn. What is fn? Fn is of type this. So can I call it as a calculate to fn1? Go accept it. You don't need to typecast it as well, actually. You don't need to typecast it. Go accept it. Because Go checks the functions that facilities are. Go understand that, okay, fn. You're creating variable of fn. What is fn? Fn is nothing but a function. Whether it is satisfying the signature with this signature, yes, it satisfies the signature with the signature. Let me pass it here. You don't need to typecast. That's what I'm telling you. You don't need to typecast like fn fn of here. You don't need to typecast basically. I can directly pass. But what if calculate one, I create another function. Here the type is fn. So calculate one. Let me print this. Calculate f1, 1, fn. What you have to pass here? You have to pass a type called fn. So calculate one, I want to call. Let me call this calculate one instead of this. Calculate one or 5. You don't need to typecast. You don't need to typecast. Typecast means what? How do you do? Function of int comma int of int. This is the type. You don't need to typecast like this. If you do also, no, not a problem. If you don't do also, not a problem, because multiply is a function of this type. I'm sorry, you don't need to typecast as fn, not required. Go can understand, because functions always work with signatures. The meaning of this is functions always work with signatures. Let's say I create a function square of maybe I create a variable called a. It gonna return a into a. You see that such a nice design, but this doesn't solve the actual purpose. What is f? F is a method. On what it works? It works on the sq. It works on fn. So you can technically call this method on f1. So where is f1? I have created f1 where somewhere I have created fn1. I can call this fn1 dot square. I can call this. So f1 is a function, and a type actually doesn't take care whether it's a function or a structure or any whatever it is. It always thinks that okay, it's a type. A type contains methods. Of course, fn also contains methods if you want to write, but you cannot use these variables. That's a different thing. But fn is a type, so you can call it as a type. That's the full concept. Okay, that's the overall concept. So you can execute it. You can execute this as well. So to summarize, I will explain more about it. Yeah, I can explain more about it. More examples we will go through. To summarize, anonymous function means a function without a name, or a function can be created as a variable. That anonymous function has got access to the global variables within the scope. A function can be passed as a parameter, can be passed as an argument to another function. Absolutely no issue at all, like a normal variable. You can create a type which is of a type function, like any type that you create. Go is very flexible in that aspect. The way how you create a type of a struct, the way how you create a type of something else, you can also create a type of a function. It's absolutely 100% accepted. There is no issue at all. Go doesn't say anything about it. Okay, this type can also attach methods and all. So technically there is no difference between a named function and a function variable. The named function can also be used as a variable as and when required. Named function can also be passed as an argument as a function, because it's a function with the variables. So ultimately what happened, a stack frame is created, the memory is allocated as much as memory that is required for this function. Here it is 8 and then 8 bytes on 64-bit, almost 24 bytes is allocated over here. Okay, a closure and anonymous functions are always same, but some programming languages they differ it, but in Go it is the same. You can use them, you can call them as a closure or anonymous function, anything is fine. Anonymous functions can be stored inside a variable and then executed later on. Okay, they can be used as a functional pointers as well. These are the things that we have to do. We will discuss more about this in the next session. Okay,